Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the another property of Fourier series, that is modulation or multiplication in time domain. In the last class, we completed the convolution in time domain. And next, coming to the multiplication or the modulation theorem. Multiplication or modulation theorem. Statement saying that if x of t is a Fourier series x of k and y of t, the Fourier series is y of k. Now observe here, the time is product or the time is multiplication. What is the frequency here? Frequency is convolution. Here the convolution symbol it is. Frequency is convolution. Previously in the convolution time is convolution, frequency is multiplication. X of k, y of k with the t. T is also there, capital T, the time period. But in the coming next property, the multiplication or the modulation theorem saying that the time is multiplied. The multiplication time, the time, the two signals x of t and y of t, the time signals is multiplied or the product. For that, the Fourier series, applying Fourier series of x of t, the y of t, the convolution of the two frequencies. For x of t, the x of k is a Fourier series. For y of t, y of k is a Fourier series coefficient. And x of k, y of k convolution for the multiplication of x of t and y of t. Okay. Let us take the same way we have to prove by taking off analysis equation here. Analysis equation z of k is equal to 1 by t the integral t z of t e power minus jk omega naught t dt. As per the definition saying that exponential Fourier series in that analysis equation. Here for this multiplication and modulation theorem, you can use both the analysis equation and the synthesis equation. Both the analysis equation and the synthesis equation. Now let us see. I'm taking another one. Multiplication or modulation. Multiplication or the modulation theorem for the property. Okay. So what is the statement saying here? If x of t, the Fourier series, x of k, y of t, the Fourier series, y of k, this is the multiplication in time. Then prove that when the z of t is equal to the multiplication of the two signals x of t, y of t, its a Fourier series is z of k is equal to the x of k convolution of, this is a convolution, my students, it's a symbol. So let us see here. Convolution of y of k. This time is multiplication, convolution is the frequency. Okay, let us go for the proof. According to the analysis equation, z of k is equal to 1 by t the integral t, 1 by t the integral t, z of t e power minus jk omega naught t dt, omega naught t dt, and is equal to 1 by t the integral t. What is the z of t? Taking out the multiplication of the two signals, time signals, y of t, x of t, and y of t, e power minus jk omega naught t dt. Okay. In this, you can substitute the x of t by the synthesis equation. We want the synthesis equation. X of t is equal to sum of k equal to minus infinite to infinite. X of k is a positive exponential, e power plus jk omega naught t. So replace the x of t with this equation, analysis equation, not the synthesis equation. So z of k is equal to, now the above equation becomes z of k is equal to 1 by t, the integral t. Now I am taking here the x of t as sum of k equal to minus infinite to infinite, x of k e power jk omega naught t. Let's take as a one function and replace only the by x of t here. Okay, and y of t, write as directly the y of t e power minus, and this function here, e power minus jk omega naught t dt, omega naught t dt. What I did here, replace the x of t by the synthesis equation in exponential Fourier series. What is that equation? X of t is equal to sum of k equal to minus infinite to infinite, x of k e power jk omega naught t. Now again rewrite this function, z of k is equal to, see, I take the 1 by t the integral t, 1 by t the integral t, and we have the y of t is there, y of t, and e power minus jk omega naught t dt. Total three terms, not the three equations here. Y of t, the e power minus jk omega naught t dt. Understood? So what is the remaining here? Whatever the branches is there, the sum of k equal to minus infinite to infinite, x of k e power jk omega naught t. X of k, sum of also that. Sum of k equal to minus infinite to infinite, x of k e power plus jk omega naught t, omega naught t. Okay, my dear students. See, here you can observe the e power minus jk omega naught t, and here e power jk plus omega naught t. You have to get cancelled. If we get cancelled, we didn't get the x of k with the convolution of y of k. Now, a small modification you have to do. Instead of k here, instead of k, once again I'm saying, instead of k, you can keep it as m is equal to minus infinite to infinite, m is equal to minus infinite to infinite, x of m j m omega naught t. Don't confuse my dear students. Simply because of you see the e power minus jk omega naught t and e power minus plus jk omega naught t. Both the bases are the same. Powers you have to add, and this one is a plus and this one is a minus. It becomes of e power 0. That value is a 1. But by using these remaining equations, whatever you have in the z of k, the x of k, and the convolution of y of k, will get that one. So I replace that k as m. Okay, k as m. So modified here also the k, and k here, k also. K as m is equal to minus infinite to infinite x of m e power jm omega naught t. Follow my students. Now here also I change it as m values. M is equal to minus infinite to infinite x of m e power jm omega naught t. Now there is no any cancellation here for the e power minus jk omega naught t, and here the e power j m omega naught is equal to sum of m is equal to minus infinite to infinite x of m, and another equation here 1 by t, the integral t y of t e power, take the common here, minus j omega j, let us take is a minus here, k minus m, k minus m, minus into minus here the plus, minus j here omega naught t, omega naught t, and this function is also the dt. Alright. So observe here this total equation as the frequency shift property saying that k minus k naught 1 by t, the integral t y of t e power minus j k minus m omega naught t dt according to the frequency shift property. And this total equation, according to the frequency shift property, the sum of n is equal to m is equal to minus infinite to infinite x of m. Now this total equation we write as according to the one of the property, frequency shift property, x of k minus k naught, when here it is a x of t, now it is a y, take it as a y, k minus k naught, k is there and k naught is not the, replace as a m value, k minus m. Sum of m is equal to minus infinite to infinite x of m y of k minus m. See, this is the equation z of k is equal to convolution sum. The convolution integral as integral t y of x of t, x of tau, y of t minus tau, d tau. As a convolution sum saying that convolution sum. Convolution sum. What is the convolution sum? The sum of k equal to minus infinite to infinite, x of k, not is a small letter, it is a capital letter. X of k y of n minus k. See, after these two equations now, instead of k, here the m. X of k, y of n minus k, and here the m. Instead of k, n, here the k value. Both are the same. So what is the relation here for these two equations? The relation is x of k with the convolution of y of k. X of k with the convolution of y of k. Z of k is equal to. Means the input, the time signals is multiplied. The Fourier series of the product of the multiplication of R, it is a multiplication of the time signals. In the frequency, the signals convolution. X of k with the convolution of y of k. So x of t, the y of t, the product of the two time signals, its Fourier series is x of k with the convolution of y of k. X of k with the convolution of y of k value. Understood? It is also very, very important, my students. Now see how explain this. The multiplication of modulation theorem. X of t, the Fourier series is x of k. Y of t, the Fourier series is y of k. Taking off the product of x of t, y of t, its Fourier series is convolution of x of k and y of k. First, I take the analysis equation. Z of k is equal to 1 by t, the integral t, z of t, e power minus jk omega naught t dt. And the z of t, take as x of t and y of t, 1 by t, the integral t, x of t, y of t, e power minus jk omega naught t dt. By the synthesis equation, see here, by the synthesis equation, x of t is equal to sum of k equal to minus infinite to infinite, x of k e power jk omega naught t, jk omega naught t. So now, putting this expression for x of t in the above equation, x of t in the above equation. See 1 by t. See already is without doing any other expressions here, directly they given 1 by t, the integral t, x of tau e power minus jk omega naught tau d tau, integral t y of m e power minus jk omega naught m and dm. They already modified. So keeping of this equation, so z of k is equal to, it becomes of what I explained the whiteboard here, z of k is equal to 1 by t, the integral t, the x of t, you can keep it as x of t is the sum of k equal to minus infinite to infinite, x of k e power jk omega naught t is multiplied here, and y of t e power minus jk omega naught t dt. So here they replace the m, y of m e power minus jk omega naught m and the dm with 1 by t, the integral t. And the summation of x of k e power jk omega naught as modified with k as here is a m. K as the m. And it becomes of 1 by t, the t x of k and the t into y of k. Why they dot? It is a t into x of k and the t into y of k. Directly they take it as x of tau, the e power minus jk omega naught tau d tau. The function as x of k function is x of k function. And this function is also with the y of m e power minus jk omega naught m dm. With 1 by t is there, it is a y of k. There is no any 1 by t, can multiply with the t here. Okay. And this total 1 by t, correctly they can take in 1 by t. For this function, 1 by t you have to get. Otherwise, you can multiply the t into x of t. And here also 1 by t with this function with the y of k. There is no 1 by t, so multiply the t. So keeping the 1 by t here and multiply the t. And for this function also 1 by t multiply with the t. So 1 by t the integral t x of tau e power minus jk omega naught tau d tau is a t into x of k. And this function with the t into y of k. So t get cancelled, the t into x of k, y of k. So this is actually for these two equations. So these two equations actually for this convolution in time, my dear students. Convolution time. Let us will modify that. So these are the two equations for the previous one. Now you can see these are the two equations. Is a little bit confusion. Now you can see is a 1 by t the x of tau e power minus jk omega naught tau d tau here, and integral t y of m e power minus jk omega naught dm df. So 1 by t they directly written here, and for this function it is a t can multiply here and 1 by t, so t into x of k, and t can multiply here 1 by t, t into y of k. So t x of k y of k. It is a convolution time proof. The multiplication factor, multiplication, the modulation theorem. So the x of t is substitute as the sum of m is equal to minus infinite to infinite x of m e power j m omega naught t. So directly taken as a k as a m. What we taken in the previously I explained here. See the sum of m is equal to minus infinite to infinite x of m e power j m omega naught t instead of k. They replace as a m as a variable. M as a variable. sum of m is equal to minus infinite to infinite x of m e power j m omega naught t. And the remaining function, the y of t e power minus jk omega naught t dt. Okay. Note that the index of the summation is changed in the above equation to differentiate between two indices. See, these two indices is the same. Whenever if you can take is a k value. The two indices of k here and m, interchanging the order of integration and summation. So by keeping directly without changing the m variable by as a k, in terms of e power 0, the value is 1. Okay. The index of the summation is changes in the above equation to differentiate between the two indices of k and m. Here the k is there and here is m. Now we can interchange the order of the integration and the summation. Integration here is a y of t and summation in the x of m. So here the sum of m is equal to minus infinite to infinite x of m 1 by t the integral t y of t e power minus j k minus m omega naught t. K minus m omega naught t. Whatever the total equation is in the parentheses we here in the brackets, according to the frequency shift property, the quantity inside the bracket indicates Fourier coefficient to y of k minus m. Y of k minus m. Hence, the above equation will be z of k is equal to sum of m is equal to minus infinite to infinite x of m, and this total quantity inside the bracket is of y of k minus m according to the one of the property, the frequency shift property. And this equation, what we have here, the sum of m is equal to minus infinite to infinite x of m y of k minus m as the convolution sum formula. The convolution sum formula. So what we already seen here, the convolution sum of k equal to minus infinite to infinite x of k y of n minus k. As a k has here the m and n as a k. So x of k with the convolution of y of k. So z of k is equal to x of k with the convolution of y of k. Understood, my dear students? Now, is a very, very important two properties today we see. One is convolution in time, and another one is a multiplication or modulation theorem. The conclusion of the two properties is x of t convolute with y of t. Its Fourier series is t into x of k y of k. Means time is convolution, frequency is product. The convolution in time. Convolution in time. Okay. Now the modulation or multiplication. So the time is product or the multiplication y of t x of t. Its Fourier series is frequency is convolution. Frequency is related with the convolution. Okay. So inverse. Time is convolution, frequency is product. If time is product, frequency is convolution. So these two properties are very important. You have to learn, practice this one. 2 or 3 times you have to practice, then you can get without any ambiguity. The x of t, the convolution of y of t, and the t into x of k, y of k. And the multiplication and the modulation theorem, x of t, y of t with the Fourier series, x of k with the convolution of y of k. Following matters.